Okay, we're going to look at one more polynomial example that really helps us look more at the multiplicity of each zero to make sure that you get that idea. So our function is h of x is equal to x squared times x plus 3 cubed times x minus 1. So we're going to do the same things with this function, and we notice that this is in factored form, which will make it easy to find the zeros, but we do need the standard form, that first term, leading term. So let's just find that first. And that would be if we multiplied everything out. Just imagine multiplying it out, and what is the first term? So x squared, this is x cubed, and this is x. So that's 2 plus 3 plus 1. So this is x to the 6th, okay? Degree is 6. There is no other leading coefficient, leading number. So the leading coefficient is going to be 1. All right, so let's analyze this. We have a degree of 6. And remember, that would be an even degree function then. We have the zeros. The zeros are what makes this function 0. So x equals, for this first x squared, 0. And then, well, let's actually write this out a little more, just because this is kind of what we're going to be talking about. Okay, so x squared equals 0. And then we have x plus 3 cubed equals 0, and then we have x minus 1 equals 0. Okay, so this 0 is x equals 0, and the multiplicity for this 0, since it's x squared, the multiplicity is 2. And also that's an even multiplicity because 2 is an even number. Okay, this 0 is -3, right? X equals -3. Notice that the degree here, the multiplicity, is 3, and that is an odd multiplicity. And then here we have x minus 1, so our 0 is x equals 1. And let's see, that happens just one time, right? That this x minus 1 term, the multiplicity is 1, and that is also an odd multiplicity, okay? It's going to affect where it touches or how it touches the graph at the zeros. All right, we also want to find the leading coefficient, which we kind of already did. Over here, the leading coefficient is just the 1x to the 6, so 1, and that is a positive number. Okay. And then we also want to know what the y-intercept is. So the y-intercept is the h of 0. So plug 0 in for x, 0 squared, 0 plus 3 cubed, 0 minus 1. Well, that's 0 times those numbers, so it's 0. So the y-intercept is equal to 0. And then we also want to talk about the end behavior. So the end behavior, as x approaches infinity, what does the y do? Okay, so remember we want to look at the degree being even, so up and up or down and down. And then we also want to look at that leading coefficient. Oh, it's positive again, so that's up and up. So positive infinity. And then as x approaches negative infinity, we're also looking at positive infinity there. Okay. Okay, so let's look at the graph for this function. Okay, so we have zeros at 0, -3, and 1. 0, 2, 3, negative 3, and 1. And then we notice that our y-intercept is also 0, so that's already there. And then we know the end behavior is both the ends of the graph are going up to infinity. Okay, now to finish this graph, we really need to consider the multiplicity. So the multiplicity at the negative 3, okay, this 0 in the middle here, is odd, and it's third degree. What that means is right there at that 0, it looks like a cubic, right? Because it's third degree right there. So it does pass through, but it also looks more like a cubic than a line, okay? It's going to be okay if you go straight through there, but really it looks more like a cubic with that little bit of a turn there. All right, now we're going to go down to a minimum, and then we're going to come back up to this 0. And what has to happen there is this is the x equals 0. That's the even multiplicity. The multiplicity is 2. So it's going to look like a degree 2 function right there. So it's going to look like a little mini parabola. Okay, so that's why it just touches the graph at the 0 and it doesn't pass through. Okay, then finally we have a 0 at 1, x equals 1, and that's odd and it's linear. So that one just goes right through, okay? Just like a line would pass through there, okay? So that's what our graph ends up looking like. And the multiplicity will really change the way the graph ends up looking, and it will, so you do need to consider that. Let's write the limits for the end behavior here. So this one we have the limit of h of x as x approaches infinity, and we know that the answer is infinity, it's going up. And over here we have the limit of h of x as x approaches negative infinity, and that is also going up, so that is infinity as well.